Hey students, welcome to third lecture of the electric vehicle technologies. So previously we discussed about the pros and cons of the technology. Along with that, how the challenges can be mitigated. So the major cost in the electric vehicle is of the battery, and this cost is also a recurring cost. So just unlike the ICE technology, where the fuel tank is not considered to be the recurring cost of the vehicle. So here, how the cost of the electric vehicle can be reduced, or how this technology can be made more cost effective and more affordable. So the battery cost reduction strategy, if we talk about the cost reduction strategy, the first is to make the energy efficient and electric vehicle. So if the overall conversion efficiency of the vehicle is increased further by employing the better motor design, as well as the better power controllers, then better tire design and better aerodynamic profile of the vehicle. So just by doing that, we can increase the overall conversion efficiency of the electric vehicle. So here we can just see that the size of battery can be reduced by 35 to 40% over the past 3 years in India. So earlier for e-autos or the autos for the electric vehicle, the earlier the watt hours consumption were 70 to 80 watt hours per kilometer, whereas presently this factor has been reduced to 45 to 50 watt hours per kilometer. This is almost a decrease of 35 to 40%. And similarly, in e-buses, earlier the 1600 watt hours per kilometer were required, whereas in the present time it is 900 watt hour per kilometer, and this has been possible by achieving or by doing more efficient electric vehicle design. The second one is by reducing the overall battery size. Smaller battery will definitely have the overall lesser cost on the part of vehicle. So then, but the problem with the smaller battery size is the range anxiety. So when we are reducing the size of battery, the vehicle will be running for the lesser size. And for that matter, the overall range of the vehicle will be less. And this won't be an appreciating factor in case of electric vehicle. Then the charging of battery may take the longer time. It is much larger than the filling of petrol in the ICE vehicle. So that would be a kind of problem with the, if we are reducing the battery size, and in between of the operation, we need to get the battery charged, then there will be a definite problem in the case of EV. So here there are three approaches which I am going to discuss. So first approach is business viability for the public transport. So in order to make the public transport more affordable, we can reduce, or we can split the battery into the smaller size. So just like shown in this particular figure, this is the overall size of battery which is required without creating the range anxiety. And but in place of having this complete battery, we can just have three smaller batteries equivalent to the one battery, and then these batteries are swappable. So what can be done, like when the one of the battery is exhausted, then the person who is owning the vehicle can swap the battery at the nearest station. So in place of getting the vehicle or getting the battery charged at the station, we can just swap the battery. An uncharged battery or discharged battery can be swapped with the charged battery directly. And then it would be just like as we are filling up the fuels in the ICE vehicles. So this is one of the strategy where, and then these battery charging would be taking place at the station itself. and there the charging can be done meticulously so that the overall charging life of the battery should not get affected. Then the challenges which would be there in the battery swapping, those needs to be addressed in order to have this particular approach. So in all, what we are proposing here, we are in place of having one single battery of the larger capacity, the smaller batteries are there, and these smaller batteries are one by one powering the vehicle. So when one battery is get discharged or the two batteries discharged, subsequently those discharged battery can be replaced with the charged battery at the charging station. So here no waiting time for the charging of battery, and that would be one of the major advantage of this particular approach. In the battery swapping, the major one of the major advantages, we can have a separate vehicle business apart from the electric vehicle, and energy business will also be evolving. So where there will be stations, and those stations would be doing the or would be charging the batteries, or and those charged batteries would be available just for the swapping purposes. So capital cost of the vehicle will be similar to the diesel and petrol vehicle, because here the batteries would be provided by the energy operator, and these energy operator would be giving you the batteries, including the fixed cost as well as the charging cost. So the operational cost today will be same as of petrol and diesel vehicle with the limited subsidy. So electric auto and buses can compete the present ICE vehicles. Then the volume of a public vehicle would make it more affordable. So these energy operators will buy the batteries in the bulk. They will setting up the charging infrastructure, and then the charging would be done at the cost itself, at the station itself. The capital cost of the vehicle is less than the petrol vehicle, and the operating cost of the vehicle will be same. Presently, it would be same as of petrol and diesel vehicle. But in the coming time, definitely this cost is also going to be decreases. So the capital cost, it would be even lesser than the cost of a petrol vehicle or the diesel vehicle, but the operating cost will be similar. So here we can clearly see the benefit of EV over the present ICE vehicle. The second approach is to have the larger battery inside the vehicle itself. As the Tesla company, it is giving you the battery in the vehicle itself for the 540 kilometers. So this is a big battery installed in the vehicle itself. And then after getting exhausted, these batteries can be charged at the public fast charger. So here the overall time will be the waiting time plus the public charging infrastructure, that is the charging time. So even if we go for the fast charging, 45 to 60 minutes will take place for charging a big sized battery. And even we go for the very fast charging, then the very fast charging will significantly impacts the life of battery. And in order to save the battery life of battery, we need to go for the expensive battery, and that will increase the overall cost of the vehicle. So second approach is applicable, or it is useful just for the vehicle, those 2% vehicle which are having the cost more than 10 lakh rupees, and these are in the premium category. So when we have discussed the scenario, vehicle scenario in the India, we have seen the 98% market is looking for a affordable solution. But the 2% which is going for the kind of premium segment, so that premium segment can have this kind of approach. So previous one approach, that was quite cost effective and affordable one, but this approach is useful for those 2% in the premium car segments or premium vehicle segments. So here in order to get rid of the range anxiety, we can have the range extenders. just like we have the stepney in our vehicle, that is the fifth tire, which can be used when the one of the tire get flattened out. So here the small batteries can be kept inside the vehicle just as a range extender batteries, and those batteries can be swapped in the nearest charging station. So that is again a kind of combinational approach for this particular segment. The third approach is the conventional approach, that is to choose the right size of battery for the desired value. So if suppose I am saying that in a day my vehicle is going to be run at for 100 kilometers, then I can have 120 or 140 or 150 kilometer range of the vehicle, and accordingly after the usual run of the vehicle, I can just charge my battery at home or at public places wherever the vehicle is getting parked. So when the people are commuting for their job purposes, so at the jobs, in the parking places, the charging infrastructure can be installed, and that charging in that charging infrastructure, the slow charging of batteries is quite possible. But then what it would be requiring? So it would be requiring the standardization of chargers and the batteries, just like the fuel standardization has taken place. And then also in this particular case, if we are going for the swappable battery solution, then that will also be requiring the standardization. Then only the particular charger will be able to charge the battery. So for that matter, the charging standards are already defined by the ministry, and these charging standards, according to these charging standards, all the chargers are getting installed at the various public places where the people can just go and then they can charge their vehicles comfortably. So here basically we have talked about that what are the three different approaches in order to reduce the overall cost of the EV. So first one was swappable battery. Then second one was the private vehicle, where the big battery is installed in the vehicle itself, and it was getting charged uh, at the home itself, and range extender battery is being used. Third approach is the conventional approach, where the desired size of the battery is installed, and then after a particular run of the vehicle can be comfortably charged at either at the home or the public places. But that requires whole requires the standardization of the chargers and the battery. And for that matter, the national as well as international charging standards are prevailing. And based upon those standards, the various chargers are getting installed at the different locations. So here we just end to the this particular lecture. In the next class, we would be talking a bit about the batteries. What is the why the capital cost of the battery is too high. So thank you very much for giving me this patient listening. Thank you.